Hi everybody, my name is James and today I'm going to show you how to do problem number 69. 3 blocks of masses, 10 kilograms, 5 kilograms, and 3 kilograms are connected by light strings that pass over frictionless pulleys as shown in figure P469. The acceleration of the 5 kilogram block is 2 meters per second squared to the left and the surfaces are rough. Find A, the tension in each string, and B, the coefficient of kinetic friction between the blocks and surfaces. Over there, B is just asking us to find the coefficient of friction. Let's start this problem by drawing the diagram. Now let's label our forces. You have weight going down here with tension 1 up here. Since they tell you that the 5 kilogram block is going to the left at 2 meters per second squared, you know that this block is moving to the left and that this block is moving down. Because they share the same string, this block will move down. And let me just draw the string right here. Since this is all connected by strings, if this is going to the left, this must be going up the incline as well. So from that we can imply that the tension here is going over there, and the tension here is going to be labeled by tension 2. And since these two are connected by this pulley, this is going to be tension 2 and this is tension 1. They are different. Let's label the normal force. Let's label the weight of this one. Normal force is perpendicular to the surface. Weight this straight down. The angle is 25 degrees and it's 3 kilograms. Okay, now this problem, when I'm gonna solve this problem, I'm not gonna use this diagram. I'm actually gonna draw 3 different simple diagrams that represent each of these blocks individually. And I'll show you what I mean. I want to draw a free body diagram just for this block, and I want it to be as simple as possible. So I'm going to leave out the details. I'm just going to use this dot for the box. It's 10 kilograms. And since weight is mass times gravity, we can just shorten this and write 10g. And that's just tension 1. And I'm going to do the same for this 5 kilogram block. I'm going to draw a really simple free body diagram because this problem can get messy. So I want my free body diagrams to look as simple as possible. This is tension 2. Oh yeah, and I forgot. Friction acts opposite and the direction of motion. So let me just add friction here. There are 2 forces acting on this 5 kilogram block in the right direction, and that would be tension 2 and friction. Same here. There's going to be friction opposite direction of motion. And we all know that is mu times the normal force. Now let's go back to the simple diagram. Tension 2 here. And just to make sure, I'm going to draw another vector that represents friction. And I'm going to draw a normal force. I'm going to label a normal force. I want to keep things simple. So I'm going to keep it simple and organized. So I'm going to label this as normal force 5. And this is tension 1. And I'm going to shorten the weight to just be 5g. For the 3 kilogram block, you can see that it is actually tilted. So normally you would solve this and tilt your axes and say that this is this is your positive x-axis, and this is your positive y-axis. But for my simple free body diagram, I don't want any tilt in my diagram. So that means when I draw my simple free body diagram in the x and y directions, it will simply be the split up components of the weight. And if you are not too sure on how to split the weight into its components, I'm just going to do up here real quick. I'm just going to redraw it here so it looks clearer. That's the box, the block. That's the weight. So when you are splitting up the weight into its components, I'm going to simplify the weight into 3g. You want to extend the normal force vector and then draw a perpendicular line from that extended vector you just drew. And if they give you an angle here, you know it's the same angle over here. So you can label this as 25 degrees. And for the y direction, it's going to be the weight cosine the angle. This is opposite of what you would usually do in the kinematics chapter, because the angle would be here. But since our angle is now up here, this is the adjacent, this is hypotenuse. That's why we're using cosine here. And likewise, that's why we're using sine down here. Since we split up our x and the weight into its x and y components, we can go back to the simple free body diagram and label the x-axis as 3g sine 25, and the y-axis as 3g cosine 25, representing weight. Now, you don't forget friction. Friction is mu times normal force. I'm going to label this normal force N3. And so I'm going to label this normal force also N3. And this x component here is your T2 from up here, except it's not tilted, so it looks just like this. Now we want to label our positives and negatives. We always want to label our positives in the direction of motion. So for this first block here, the block is going down. It's going down. So I'm going to label this positive and this negative. Likewise here, this block is going to the left. So I'm going to label this positive and this negative. And it doesn't really matter too much here. And same for this one, the direction of motion is that way. So I'm going to label that positive and negative. Doesn't really matter here. And before we move on, to make, just as a handy reminder, you want to label the acceleration, just so we don't forget later. Now that we have all of our simplified free body diagrams, let's start solving the problem. They want us to find the tension in the string, so let's just start with tension 1. So if I want to find tension 1 here, I can actually sum up my forces in the y direction for the 10 kilogram block, and I could just isolate T1. The reason why this works is because usually they won't give you the acceleration, but since they do, your only unknown when you sum up the forces will be T1, and I'm going to show you right now. Always remember that you take your positive force minus your negative force. That's going to be weight minus T1 equals mass times acceleration. So usually you would be solving for this, but since they give it to you and you know the mass, this is really your only unknown. That means solving for the tension in string 1 is really easy. It's just do that. Move over to 10g. Divide by -1, and you get 10g minus 20. I'm going to leave it like that right now. I'm not going to plug in 9.8 for g. That's just going to make things simpler later. With that, now I'm going to want to sum the forces in the y direction for the 5 kilogram block. we know what's tension 1, so we're just going to leave that there for now. But since they give us acceleration, we can actually find the normal force of this 5 kilogram block really easily. And I'm going to show you some of your forces in the y direction. It's the positive direction minus the negative force, which is 5g. And since this block is not moving up or down, the mass times acceleration is just going to be 0. And since this is 0, normal force, you already have it, it's just 5g. Again, we're just going to leave it as in terms of g. We'll make things simple. And we might as well solve for the normal force of this while we're at it, because it's really easy. We can just get off the way and it'll help us solve for our coefficient of friction later. So it's going to be the normal force of the 3 kilogram block minus 3g cosine 25. This is the weight of this block. It looks weird because it's tilted. Equals 0. Normal force of the 3 kilogram block is 3g cosine 25. You have your normal forces and you have tension 1, but you still have 2 unknown variables, and that is tension 2 and the coefficient of friction. Usually when you have 2 unknown variables, you can solve it through a system of equations. But your system of equations, you need 2 equations. And so where are you going to get those equations? You can get those equations by summing the forces in the x direction of this block and this block. So let's start by summing the forces in the x direction of the 5 kilogram block. It's going to be your positive x force minus tension 2 minus the minus friction, which is the coefficient of friction, times your normal force, and your normal force is 5g, equals the mass times the acceleration. Let's clean it up. We have T1 here, and we already solved for T1, so let's plug it in. Now we just want to get only our unknown variables on the left side. So we're going to move over 10g minus 20. It's going to be 10 minus 10g plus 20. Now I'm going to simplify it by dividing by -1. It will give you -10 plus 10g minus 20. We'll clean it up again. You'll get 10g minus 30. And now let's just leave it like that. Now you can see this is already starting to look like a system of equations with your 2 unknowns here. You can just imagine it as x and y. It doesn't matter. Now we are going to get our second equation by summing our forces in the x direction of the 3 kilogram block. So let's just do that. 3. It's going to be tension 2 minus the x component of the weight, which is 3g sine 25, minus friction also, which is the coefficient of friction times a normal force. And a normal force for the 3 kilogram block is 3g cosine 25 times the mass, which is 3 kilograms times acceleration. Now let's just clean it up. It's gonna equal 6. Now we want to get only our unknowns on the left side. As you can see, our unknowns are T2 and the coefficient of friction. This we know because we already know G, so we want to put that on the other side. So T2 minus the friction equals 6 plus 3g sine 25. Now you can see you have this equation and this equation. You you can solve it like how you normally would solve your system of equations. In my opinion, the easiest way to solve this would be by substitution. So I'm going to solve for just t2 with this equation, and I'm going to substitute that t2 back into here so I can just solve for the coefficient of friction. Let's do that. I'm going to get 10g minus 30 minus 5g mu. Now since that is t2, I can plug that into here, substitute it in. It's going to be 10g minus 30 minus 5g mu and minus all this. Cosine 25 equals 6 plus 3g sine 25. Things are going to get really messy here, so let's be careful. You want only your unknowns here, so anything that does not have the coefficient of friction, move it over. Since these two have nothing to do with the coefficient of friction, I'm going to move it over. It's going to be 6 plus 3g sine 25 minus 10g plus 30. Now, I'm just going to clean up a little bit. It's going to be negative 10g plus 3g sine 25 plus 36. These negatives, let's just make our life easier by dividing by -1 here. It's going to be actually positive 10g here. Minus 3g sine 25 minus 36. Now that you are here, you just want to solve for this coefficient of friction. You can actually just pull out this coefficient of friction, like factor it out, and it will look like this: 5g plus 3g cosine 25. And with that, you can just divide this whole thing by that, and you would have just the coefficient of friction. Okay, you're gonna wanna put this in your calculator. Be very careful with how you plug in 9.8. It's really easy to mess this up, but you should get a number. You should get 0.655. And let me just check if this is all right. Yeah, you should get 0.655. And with the coefficient of friction here, you can plug it back into you can plug it back into here to solve for tension 2. It's 10g minus 30 minus 5g 0.655, and you should get 35.89 newtons. That's tension 2. You can go back up here and finally solve it again, because we wanted to make it simple, so we just left it there. So that's your tension 1, that's your tension 2. This is your coefficient of friction, and that's it. That's all you're asking for. If you are still trying to solve, if you find that every time you put this into your calculator and you plug in 9.8 and you're still not getting 0.655 for some reason, there's actually a pretty cool trick you can do in your calculator that will make this extremely easy. As you can see, if I try to do it the traditional way, which is plugging in 9.8 minus 3 9.8 and sine 25, this already looks extremely messy and there's a lot of room for error. So you can actually make use of these you can actually make use of these the letters that they give you. So if G is supposed to be 9.8, we can actually tell the calculator what to input for G. And to do that, since you want G to be 9.8, you do 9.8. And there's this store button here. So you're going to press store, and then do alpha, and then this button here so you can get G. So you're telling the calculator to store 9.8 into the letter G, and that confirms it. So every time I use G in my calculations now, I will get 9.8. So this makes it really easy to compute this now. You can do 10G minus 3 and use G again. It makes it look cleaner. It's almost really hard to mess this up now once you have the G in there. G, 5G plus 3G cosine 25, and you get 0.655. And you can put, this, you have a lot of freedom with this. You can input, you can even assign the U button in your calculator to be the coefficient of friction. So it makes it, easier to plug it in here too. Play around with it, and if you use, if you store 9.8 as G, it'll make it really easy to solve complicated fractions like this.